Right now, you are surrounded by ghosts. Not supernatural ghosts. Not spirits. Not creatures hiding in the darkness. Something far stranger. Something real. In fact, every star you've ever seen, every planet, every galaxy, every atom in your body makes up less than 5% of the universe. Let that sink in. Everything humanity has ever touched, studied, photographed, or explored is only a tiny fraction of reality. The remaining 95%? Invisible, untouchable, mysterious. We call it dark matter and dark energy. But those names can be misleading because they're not explanations. They're admissions of ignorance. Labels we've given to something we don't understand. And what makes this mystery terrifying is that these invisible forces control the fate of the cosmos. They shape galaxies, bend space-time, and may ultimately determine how the universe ends. Yet despite decades of research, we still don't know what they are. Tonight, we're diving into one of the greatest mysteries in science. A mystery hidden in plain sight. A ghost in the machine of reality itself. And by the end of this journey, you'll understand why some physicists believe we're only seeing a tiny shadow of the true universe. Imagine being born blind inside a vast palace. You can touch walls, feel floors, hear echoes, but you'll never see the structure around you. Your understanding remains incomplete. Now, imagine humanity is in a similar position. For centuries, we believed we were uncovering the secrets of the cosmos. We mapped planets, measured stars, discovered galaxies, unlocked the atom, split the nucleus, created quantum mechanics, developed relativity, and then we realized we had barely scratched the surface. The universe was hiding something, something enormous, something invisible, and the clues appeared in the most unexpected places. Galaxies were moving incorrectly. Stars were orbiting too fast. The cosmos itself seemed to be accelerating. The equations didn't add up. Reality wasn't behaving as expected. At first, scientists thought they had made mistakes. But what happened next changed everything. Because the universe wasn't wrong. Our understanding was. And that realization opened the door to one of the greatest scientific mysteries of all time. The mystery of the invisible universe. Chapter 1. The night the universe stopped making sense. Imagine standing beneath the night sky in the early 20th century. Astronomers believed they were living in an understandable universe. A universe governed by gravity. A universe made of stars, planets, gas, and dust. A universe that followed predictable rules. Then something strange happened. The deeper scientists looked, the less sense the cosmos made. At first, the anomalies seemed small. Tiny inconsistencies. Unexpected measurements. Nothing alarming. But anomalies have a habit of growing. And eventually, one astronomer would stumble upon evidence so shocking that it would challenge everything humanity thought it knew about reality. Her name was Vera Rubin, and her discovery would reveal the first ghost hiding in the cosmic machine. But before we get to Rubin's groundbreaking work, we need to understand how galaxies were supposed to behave, because only then can we appreciate just how bizarre the truth turned out to be. Chapter 2. The Galaxy Problem. Picture a merry-go-round. The closer you are to the center, the faster you complete a circle. The farther away you move, the slower your motion becomes. This behavior appears throughout nature. It's predictable, logical, expected. Astronomers assumed galaxies worked the same way. Stars near the center should orbit quickly. Stars farther away should move more slowly. Simple, or so everyone thought. When scientists finally measured those speeds, they expected confirmation. Instead, they found a paradox. The outer stars weren't slowing down. They were moving far too fast. Fast enough that galaxies should have flown apart. But they didn't. Something was holding them together. Something invisible. At first, researchers suspected measurement errors. Faulty instruments. Incomplete data. Yet every new observation produced the same result. Again, and again, and again. Galaxies behaved as though they contained enormous amounts of unseen mass. Mass that neither emitted nor reflected light. Mass that appeared completely invisible. The implications were staggering, because if the measurements were correct, then most matter in the universe wasn't visible at all. And what most people don't know is that this mystery was only beginning, because soon scientists would discover evidence on a much larger scale. Evidence suggesting that invisible matter dominates the cosmos. Chapter 3. The Woman Who Found the Invisible. Science often remembers discoveries, but sometimes it forgets the people behind them. Vera Rubin changed our understanding of the universe. Yet for years, her work struggled to receive the recognition it deserved. In the 1960s and 1970s, Rubin carefully measured how stars moved inside galaxies. The results were astonishing. According to everything physicists understood about gravity, the outer stars should slow dramatically. They didn't. Their speeds remained almost constant. Imagine swinging a ball on a string. Now, imagine the ball continues moving rapidly even after the string disappears. That's essentially what Rubin observed. Galaxies appeared to possess invisible gravitational glue, an enormous hidden mass surrounding them. And the numbers were shocking. Not 10% more mass, not 20%. In many cases, galaxies appeared to contain 5 times more invisible matter than visible matter. The stars were only the tip of the iceberg. The real galaxy remained hidden. At first, some scientists resisted the conclusion. After all, invisible matter sounded extraordinary. But evidence kept accumulating. Eventually, resistance became impossible. The universe contained something unseen, something massive, something everywhere. Today we call it dark matter. But naming a mystery is not the same as solving it. And despite decades of investigation, we still don't know what dark matter actually is. Yet the story becomes even stranger, because dark matter turned out to be only part of the invisible universe. A much bigger shock was waiting, one that would force physicists to rethink the future of the cosmos itself. Chapter 4. Weighing the Universe. Imagine trying to weigh a ship hidden inside dense fog. You can't see the vessel, but you can observe the waves it creates. The disturbances reveal its presence. Astronomers use a similar strategy. They measure gravity. Gravity reveals mass. Mass reveals hidden structures. Over time, researchers developed increasingly sophisticated methods for weighing the universe. Galaxy clusters became crucial. These giant collections contain hundreds or even thousands of galaxies bound together by gravity. When scientists calculated the amount of visible matter inside these clusters, something didn't add up. There wasn't enough mass to explain their behavior. Not even close. The clusters should have dispersed long ago. Yet they remained intact. Again, invisible mass appeared to be holding everything together. Then came gravitational lensing, one of the most beautiful predictions of Einstein's theory of relativity. Mass bends space-time. Light follows those curves. As a result, massive objects can distort distant images like cosmic magnifying glasses. Astronomers began using these distortions to map invisible matter. And what they found was extraordinary. Dark matter wasn't merely present. It was everywhere, surrounding galaxies, connecting clusters, forming enormous cosmic structures spanning millions of light years. The visible universe appeared embedded within an invisible framework, like glowing cities built atop hidden foundations. But what exactly was this invisible substance? And why couldn't we detect it directly? Those questions would launch one of the greatest scientific hunts in history. And the search continues to this day. Chapter 5. The Cosmic Web. If you could see dark matter, the universe would look completely different. The stars would no longer dominate the cosmos. Galaxies would no longer appear isolated. Instead, you would witness an immense network stretching across space. A colossal cosmic web. Invisible filaments connecting galaxy clusters like strands of a gigantic spiderweb. This hidden architecture guides the formation of galaxies, shapes cosmic evolution, and influences everything we observe. Without dark matter, the universe as we know it might never have formed. Think about that. The stars you see exist because of something you cannot see. The visible cosmos may owe its existence to an invisible one. But what happened next changed everything. Because just as scientists were beginning to accept dark matter, another mystery emerged. A mystery even larger, even stranger, and potentially more terrifying. Because dark matter accounts for only about 27% of the universe. The remaining mystery? Roughly 68%. And nobody saw it coming. To be continued. Chapter 6. The discovery nobody expected. Imagine spending decades trying to understand one cosmic mystery, only to discover an even bigger one. That's exactly what happened in the late 20th century. By the 1990s, astronomers believed they had a rough understanding of the universe's future. Gravity should be slowing cosmic expansion. The question wasn't whether expansion would slow. The question was how much. Would gravity eventually stop expansion? Would the universe collapse in a big crunch? Or would it expand forever at a gradually decreasing rate? Researchers set out to find the answer, and they used exploding stars to do it. These stellar explosions, called Type I supernovae, act like cosmic lighthouses. Their brightness allows astronomers to measure enormous distances across space. The plan seemed straightforward. Measure distant supernovae, calculate cosmic expansion, determine the universe's fate. Simple. Then the data arrived, and nothing made sense. The supernovae appeared dimmer than expected, farther away than they should have been. At first, researchers suspected mistakes, faulty measurements, instrument problems, dust clouds interfering with observations. Anything but the obvious explanation. Because the obvious explanation sounded impossible. The universe wasn't slowing down. It was speeding up. Chapter 7. The Accelerating Cosmos. Think about throwing a ball into the air. Gravity slows it down. Eventually it stops. Then it falls back. That's how gravity behaves. Attractive, pulling things together. Now imagine throwing a ball upward and watching it accelerate away from you. Faster and faster and faster. That's essentially what astronomers discovered happening to the universe. Galaxies weren't merely moving apart. Their separation was accelerating. Something was overpowering gravity itself. Something pushing space-time outward. Something invisible. The discovery shocked the scientific community. 3 independent research teams reached similar conclusions. Again, and again, and again, the evidence became overwhelming. The universe contained a mysterious force driving accelerated expansion. A force unlike anything ever observed. A force that appeared to dominate the cosmos. Scientists eventually gave it a name. Dark energy. But just like dark matter, the name explained nothing. It merely labeled the mystery. And what most people don't realize is that dark energy may be the strangest thing ever discovered. Because it doesn't simply affect galaxies. It affects reality itself. Chapter 8. Einstein's biggest mistake. Sometimes history plays strange jokes. In 1917, Albert Einstein faced a problem. His equations suggested the universe should either expand or contract. Yet most scientists believe the universe was static, unchanging, eternal. So Einstein modified his equations. He introduced something called the cosmological constant, a mathematical term designed to counteract gravity, a kind of repulsive force, a cosmic balancing mechanism. Years later, astronomers discovered the universe was expanding. Einstein reportedly called the cosmological constant his greatest blunder. He believed the modification had been unnecessary. The universe didn't need balancing. Expansion solved the problem. Case closed. Or so it seemed. Then came the discovery of dark energy. And suddenly Einstein's discarded idea returned from the grave. Because dark energy behaves remarkably like a cosmological constant. The term Einstein introduced to solve a non-existent problem may have accidentally predicted one of the deepest mysteries in modern physics. The irony is almost unbelievable. But the real story is even more surprising. Because dark energy appears to dominate the universe. Not matter, not stars, not galaxies. Dark energy, and its influence is growing. Chapter 9. The universe is disappearing. Imagine living in a city where every building moves away from every other building. At first, the movement is barely noticeable. Then it accelerates. Soon the distances become enormous. Eventually, entire neighborhoods vanish beyond the horizon. Something similar is happening across the cosmos. As dark energy drives expansion, distant galaxies drift farther away. Over billions of years, many will disappear from view entirely. Future civilizations may look into the night sky and see far less than we do today. The evidence for the Big Bang could become impossible to detect. Entire regions of cosmic history will fade beyond observation. Think about that. Humanity may live during a uniquely privileged era. An era when the universe still reveals its origins. An era when the cosmos remains visible. In the distant future, much of that evidence may be gone forever. Dark energy isn't merely shaping the future. It's gradually isolating galaxies from one another, turning the cosmos into a lonelier place. But that raises an unsettling question. If dark energy continues growing stronger, how does the story end? The answer depends on what dark energy actually is. And that's where things become truly frightening. Chapter 10. The Possible Ends of Everything. For most of human history, the fate of the universe was unknown. Today we have theories, and some are terrifying. One possibility is called the Big Freeze. Expansion continues forever. Galaxies drift apart. Stars eventually die. Black holes evaporate. The universe grows colder and darker, until almost nothing remains. Another possibility is even stranger. The Big Rip. If dark energy strengthens over time, expansion could become increasingly violent. First galaxies separate, then solar systems, then planets, eventually atoms themselves. The fabric of reality tears apart. Everything ends. Every structure, every particle, every possibility for life, ripped apart by accelerated expansion. Most physicists consider this unlikely, but not impossible. Then there's the possibility we haven't even imagined the correct ending yet. Because the truth is simple. We don't know what dark energy is, and until we understand its nature, predicting the future remains extraordinarily difficult. Which brings us to one of the greatest scientific mysteries ever faced. What exactly are dark matter and dark energy? Because together they account for roughly 95% of the cosmos. Yet we still don't know their true identities. Chapter 11. The Hunt for Dark Matter. Imagine knowing a tiger lives in your house. You hear it. You see evidence of its presence. You observe its effects. Yet every room appears empty. That's the challenge physicists face with dark matter. Its gravitational influence is unmistakable, but direct detection remains elusive. For decades, researchers have built increasingly sophisticated experiments. Underground laboratories, massive detectors buried beneath mountains, ultra-sensitive instruments shielded from interference, all searching for a single interaction, a single signal, a single clue. One popular candidate became known as the WIMP, weakly interacting massive particle. For years, WIMPs seemed promising. Many physicists expected discovery at any moment. Yet the experiments remained silent. Years passed. Nothing. Then decades. Still nothing. The mystery deepened. Perhaps dark matter wasn't a WIMP after all. Perhaps researchers were searching in the wrong place. New possibilities emerged. Axions, sterile neutrinos, primordial black holes, entirely new forms of matter. The list continued growing, and the hunt continues today, because solving dark matter could transform physics forever. But what if the solution is even stranger than anyone expects? Chapter 12. What if we're asking the wrong question? Science progresses by challenging assumptions. And sometimes the most dangerous assumption is the one nobody notices. Most researchers assume dark matter exists. But some scientists have proposed an alternative possibility. What if gravity itself behaves differently on cosmic scales? What if the equations need modification? The idea remains controversial, yet highlights something important. The mystery isn't solved. Dark matter explains many observations remarkably well, but science remains open to alternatives. That's how progress works. Evidence decides, not preference, not popularity, not authority. Nature determines which ideas survive. And so far, nature continues guarding its secrets. But one thing has become increasingly clear. Whether dark matter exists as a particle, or gravity behaves differently than expected, the visible universe is only a small part of reality. A much larger hidden structure surrounds us. A structure we're only beginning to understand. So far, we've uncovered two invisible giants, dark matter and dark energy. Together, they dominate the cosmos. Together, they shape the destiny of galaxies. Together, they account for roughly 95% of reality. Yet the biggest questions remain unanswered. Were they? Where do they come from? And could they reveal an entirely new layer of physics hiding beneath everything we know? In the next part, we'll explore the most compelling dark matter candidates, the hidden architecture of the cosmic web, the role of black holes in the invisible universe, and the growing possibility that the greatest discovery in science may still be waiting for us. Because what most people don't know is that every new clue seems to make the mystery even deeper. To be continued. Chapter 13. The Invisible Particle Hunt. Imagine standing in a vast forest at night. You hear footsteps. Branches break. Leaves rustle. Something enormous is moving nearby. You know it's there. Every clue points to its existence. Yet no matter where you shine your flashlight, you see nothing. That is the current state of dark matter research. Physicists have spent decades chasing something they cannot directly see. And despite billions of dollars invested in experiments, the mystery remains unsolved. But what happened next changed the search completely. Instead of looking for one possible answer, scientists began developing an entire zoo of candidates. And some of them sound like science fiction. The first major contender became known as the WIMP, a weakly interacting massive particle. The idea was elegant. Dark matter particles would possess mass. They would exert gravity, but they would barely interact with ordinary matter, meaning trillions could pass through your body every second without you noticing. In fact, if WIMPs exist, they're passing through you right now, through your skin, through your bones, through Earth itself, without leaving a trace. It sounds impossible, yet the mathematics works, at least on paper. For years, physicists believed WIMPs would soon be discovered. Massive underground detectors were built. Experiments became more sensitive. Expectations grew. Then came disappointment. Nothing appeared. The detectors remained silent, and the mystery deepened. Chapter 14. The particle too small to see. When one theory struggles, science adapts. And that's exactly what happened. A new contender emerged, the axion. Unlike WIMPs, axions would be incredibly light, almost unimaginably light, tiny beyond comprehension. Yet there could be enormous numbers of them, enough to account for all dark matter. The idea initially arose from a completely different problem in particle physics. But researchers quickly realized something remarkable. Axions possessed many of the properties dark matter seemed to require. Invisible, stable, weakly interacting, abundant, perfect, or perhaps too perfect. Today, laboratories around the world are searching for axions using some of the most sensitive instruments ever constructed. Scientists are attempting to convert axions into detectable particles using powerful magnetic fields. It's like trying to hear a whisper from the other side of the observable universe. Yet researchers continue listening, because finding axions would revolutionize physics overnight. Entire textbooks would need rewriting. Our understanding of reality would expand dramatically. But what if both WIMPs and axions are wrong? What if dark matter isn't a particle at all? That's where the story becomes truly strange. Chapter 15. The Black Hole Theory. Imagine going back to the earliest moments after the Big Bang. The universe is unimaginably dense, unimaginably hot. Violent fluctuations ripple through reality itself. Now, imagine some of those fluctuations collapse into tiny black holes. Not giant monsters consuming stars. Microscopic black holes. Ancient black holes. Primordial black holes. Objects born before the first galaxies. Before the first stars. Before the first planets. Some physicists wonder whether these ancient relics could account for dark matter. The idea is controversial, yet fascinating, because black holes already possess one essential property. They are dark, completely invisible except through their gravitational effects. Exactly the behavior dark matter displays. Researchers have searched for evidence. Some results appear promising. Others raise doubts. The debate continues. And that's the beauty of science. The universe doesn't care which theory we prefer. Only evidence matters. Yet regardless of which candidate eventually wins, one thing remains clear. Something invisible dominates the cosmos, and its influence extends far beyond individual galaxies. Because dark matter helped build the universe itself. Chapter 16. The Architect of Galaxies. Imagine trying to construct a skyscraper without a steel framework. The structure would collapse. It would never reach the sky. Dark matter appears to serve a similar role in cosmic evolution. Without it, galaxies may never have formed. After the Big Bang, ordinary matter faced a problem. Light exerted pressure. Matter remained hot. Structure formation was difficult. Yet, dark matter didn't interact with light. It began clumping much earlier, creating invisible gravitational wells. When ordinary matter finally cooled, it fell into those wells. Stars ignited. Galaxies emerged. Clusters formed. The visible universe took shape. In a very real sense, dark matter acted as cosmic scaffolding, an invisible framework supporting everything we see. Think about that. The Milky Way exists because of something we cannot observe directly. Earth exists because of something invisible. You exist because of something invisible. The ghost built the machine, and the machine became the cosmos. But what does this invisible framework actually look like? The answer is breathtaking. Chapter 17. The Cosmic Web. If human eyes could see dark matter, the universe would resemble a giant neural network. Filaments stretching across billions of light years. Massive intersections connecting galaxy clusters. Vast voids between them. A cosmic web of staggering scale. Computer simulations reveal these structures in extraordinary detail. And what's remarkable is how closely they match reality. The visible galaxies appear embedded inside invisible rivers of dark matter, like cities built along unseen highways. The largest structures in existence owe their form to this hidden architecture, and the scale is almost impossible to comprehend. Some filaments stretch hundreds of millions of light years, distances so vast that light itself requires millions of years to cross them. Yet, dark matter binds these regions together, creating order from cosmic chaos. The more scientists map the web, the more astonishing it becomes, because the universe increasingly resembles a living network, a giant interconnected system. And some researchers have noticed a curious similarity, one that borders on the uncanny. Chapter 18. The Universe and the Human Brain. Pause for a moment. Imagine looking at an image of neurons inside the human brain. Complex networks, interconnected pathways, information flowing between nodes. Now compare that image to maps of the cosmic web. At first glance, the resemblance is surprising, almost eerie. Both display network structures. Both exhibit clustering. Both reveal enormous complexity emerging from simple rules. Of course, the universe is not a giant brain. At least, not according to mainstream science. Yet the visual similarity captures something profound. Nature often builds complexity through networks. Connections create structure. Structure creates behavior. Behavior creates emergence. The same principle appears throughout reality. From neurons, to ecosystems, to galaxies, to the cosmic web itself. And perhaps that's why the invisible universe feels so mysterious. Because we're not merely discovering hidden matter. We're uncovering hidden architecture, the deeper blueprint underlying reality. But what most people don't know is that another invisible mystery may be lurking within that blueprint, one involving black holes, and it may change everything. Chapter 19. The Monsters at the Center of Galaxies. At the center of nearly every large galaxy lies a monster, a supermassive black hole. Some contain millions of solar masses. Others contain billions. These giants shape galactic evolution, influence star formation, and help regulate entire cosmic ecosystems. Yet their origins remain mysterious. How did they become so massive so quickly? Some researchers suspect dark matter may be involved. Others propose entirely new physics. And the deeper scientists investigate black holes, the stranger they become. Information paradoxes, event horizons, quantum effects, space-time distortions. Again and again, black holes force physicists to confront uncomfortable questions, questions about reality itself. And increasingly, those questions intersect with dark matter research, as if multiple cosmic mysteries are connected beneath the surface. Perhaps they're separate puzzles. Perhaps they're pieces of the same puzzle. Nobody knows. Yet one thing is becoming increasingly clear. The invisible universe may hold answers to some of physics' deepest questions. And that realization has inspired a new generation of researchers. Researchers who believe we may be approaching a scientific revolution. Chapter 20. The Coming Revolution. History teaches a powerful lesson. Whenever science discovers something it cannot explain, a revolution often follows. The motion of planets led to Newton. The speed of light led to Einstein. Atomic mysteries led to quantum mechanics. Today, dark matter and dark energy represent similar challenges. The standard model of particle physics cannot explain them. Our best cosmological theories describe their effects, but not their true nature. Something is missing, a hidden chapter in the story of reality. And somewhere in laboratories, observatories, underground detectors, and supercomputers around the world, scientists are searching for it. Perhaps the answer is a new particle, perhaps a new force, perhaps a modification of gravity, perhaps something nobody has imagined yet. The universe has surprised humanity before. There's no reason to think it has stopped. In fact, the biggest surprise may still be waiting. So far, we've explored dark matter candidates, primordial black holes, the cosmic web, and the invisible architecture shaping the universe. But the story is about to become even stranger, because in the next part, we'll investigate dark energy in far greater depth. We'll explore whether empty space itself contains energy, whether the vacuum of reality is truly empty, why the expansion of the universe may be connected to quantum physics, and why some scientists believe the greatest mystery in existence isn't dark matter at all. It's dark energy, because dark matter explains roughly 27% of reality. Dark energy explains nearly 68%, and we understand it even less. To be continued. Hashtag the ghost in the machine. Why 95% of the universe is completely invisible. Hashtag part 4. Chapter 21. The mystery of empty space. Let's begin with a question. What is nothing? At first, the answer seems obvious. Nothing is simply the absence of something. An empty room, an empty box, a vacuum. But physics has discovered something deeply unsettling. True emptiness may not exist. Imagine removing every atom from a region of space. Every particle, every photon, every trace of matter. What's left? For centuries, scientists would have answered, nothing. Today, many physicists would disagree. Because according to quantum mechanics, even empty space isn't empty. It's alive. Invisible fields fluctuate constantly. Particles appear and disappear. Energy emerges and vanishes. The vacuum behaves less like nothing and more like a restless ocean, a sea of hidden activity beneath reality. And this strange discovery may hold the key to understanding dark energy. Because what if the force accelerating the universe comes from empty space itself? At first, the ideas sound absurd, but the equations suggest otherwise. And what happened next created one of the greatest crises in the history of physics. Chapter 22. The worst prediction ever made. Science is usually proud when theory matches observation. But occasionally, theory and observation collide in spectacular fashion. This is one of those cases. When physicists calculated the amount of energy that should exist in empty space, they obtained an enormous number. Not slightly wrong, not moderately wrong, catastrophically wrong. The prediction exceeded observations by roughly 10 superscript 1 superscript 2. That's a 1 followed by 120 zeros. A number so large it's difficult to comprehend. Many physicists consider it the worst prediction in scientific history. Think about that. Our best theories suggest empty space should contain vastly more energy than we observe. Yet the universe behaves very differently. Somehow, something is canceling almost all of that energy, but not quite all of it. A tiny remainder appears to survive, and that tiny remainder may be responsible for accelerating the expansion of the cosmos. This discrepancy is known as the cosmological constant problem, and despite decades of effort, nobody has solved it. Not Einstein, not Hawking, not the world's leading theorists. The mystery remains, waiting. And perhaps hidden inside that mystery lies a completely new understanding of reality. Chapter 23. The Energy of Nothing. Imagine a bank account containing $1 trillion. Now imagine spending nearly all of it. Only a few cents remain. Those few cents wouldn't seem important, unless they controlled the fate of the universe. That's essentially the situation physicists face. Dark energy appears tiny compared to the enormous vacuum energy predicted by theory. Yet that tiny amount dominates the cosmos. It determines how galaxies separate, how space-time evolves, how the future unfolds. And what's remarkable is that dark energy appears remarkably uniform. No matter where astronomers look, they observe similar effects. It's as if empty space itself possesses a built-in property, a hidden energy woven into the fabric of reality. If true, then the vacuum isn't passive. It's active, dynamic, powerful. The emptiest regions of the universe may secretly contain one of the most influential forces in existence. And that realization leads to a disturbing possibility. What if empty space is not merely a backdrop for reality? What if empty space is reality? Chapter 24. The Terrifying Power of the Vacuum. Picture the vast emptiness between galaxies. No stars, no planets, no gas clouds, nothing visible for millions of light years. Most people imagine these regions as irrelevant. Dead space, unused space. But what if that's where the real action is happening? Because dark energy doesn't live inside stars. It doesn't concentrate inside planets. It appears to belong to space itself. And that changes everything. Imagine an invisible force distributed throughout the entire universe. Not localized, not clustered, everywhere. The larger the universe becomes, the more space exists. The more space exists, the greater dark energy's total influence. This creates a bizarre feedback loop. Expansion creates more space. More space increases dark energy's influence. Dark energy drives more expansion. The cycle continues. For billions of years. Perhaps trillions. Perhaps forever. And that means the emptiest regions of reality may ultimately dominate its future. The vacuum wins. The galaxies lose. But the story becomes even stranger. Because some physicists wonder whether our universe occupies only one vacuum state among many possibilities. And that idea leads directly into one of the most unsettling concepts in modern cosmology. Vacuum decay. Chapter 25. The end of everything in an instant. Imagine waking up tomorrow. The sky looks normal. The earth feels normal. Reality seems unchanged. Then suddenly, everything ceases to exist. Not because of an asteroid, not because of supernova, not because of a black hole, because reality itself changes. This nightmare scenario is called vacuum decay. And while highly speculative, It emerges naturally from some areas of theoretical physics. Here's the basic idea. The vacuum of space may not occupy its most stable state. Instead, reality could exist in a temporary configuration, a false vacuum, a metastable condition. If a more stable state exists, a transition could theoretically occur. A bubble would form, expanding outward at nearly the speed of light. Inside the bubble, the laws of physics might differ completely. Atoms could become unstable. Chemistry could cease to function. Matter itself could become impossible. The terrifying part? No warning. No escape. No detection. The bubble would arrive before information about it could reach us. Fortunately, there is no evidence this will happen anytime soon. Perhaps not ever. But the fact that modern physics even allows such possibilities reveals how strange reality truly is. And as unsettling as vacuum decay sounds, the next mystery may be even larger. Because some researchers suspect dark energy isn't merely energy. It may be evidence of hidden dimensions. Chapter 26. The hidden dimensions of reality. Right now, you experience 3 dimensions of space. Length, width, height. Add time, and we obtain space-time. Simple, intuitive, familiar. Yet many advanced theories suggest reality contains more dimensions than we perceive. Perhaps many more. String theory, for example, requires additional dimensions to function mathematically. These dimensions may be compactified, curled up, hidden beyond ordinary observation. And some physicists have wondered whether dark energy could be connected to these unseen dimensions. Could energy be leaking between realities? Could gravity be spreading into hidden dimensions? Could the acceleration of the universe be a symptom of deeper structures beneath space-time? Nobody knows. Yet the possibility remains fascinating. Because throughout history, every major scientific revolution has revealed hidden layers beneath appearances. Invisible microbes, invisible atoms, invisible radiation, invisible dark matter. Perhaps hidden dimensions represent the next layer waiting to be discovered. And if they exist, our understanding of reality may once again require a complete rewrite. Chapter 27. The Multiverse Possibility. Now we arrive at one of the most controversial ideas in modern science. The multiverse. The notion that our universe may be one among countless others. Some versions emerge naturally from inflationary cosmology. Others arise from string theory. Still others originate from quantum mechanics itself. The details differ, but the basic concept remains similar. Reality may be vastly larger than the observable universe. Far larger, perhaps infinitely larger. If true, dark energy might play a role in separating these cosmic regions. Or perhaps each universe possesses its own vacuum energy, its own physical laws, its own constants, its own history. This remains highly speculative. There is currently no direct evidence for a multiverse. Yet the possibility continues attracting serious attention from some of the world's leading physicists. Why? Because certain mysteries become easier to explain if many universes exist. The apparent fine-tuning of physical constants, the value of dark energy, the structure of reality itself. Whether the multiverse exists remains unknown, but its emergence demonstrates just how far scientists have been pushed by the invisible universe. The mystery has become so profound that even multiple universes now appear on the table. And astonishingly, we're still not finished. Chapter 28. Why dark energy may be the biggest mystery in science. Dark matter is mysterious. Dark energy is terrifying. Because dark matter at least behaves like matter. It exerts gravity. It forms structures. It makes intuitive sense. Dark energy is different. It appears almost alien. It doesn't cluster. It doesn't form galaxies. It doesn't build stars. Instead, it opposes gravity on cosmic scales, and it dominates reality. Think about that. The largest component of the universe is something we barely understand. Not 10%, not 20%, nearly 70%. Imagine opening a book and discovering that 70% of the pages are missing. That's our current situation. We possess fragments, clues, observations, yet the central mystery remains unsolved. And perhaps that's what makes modern cosmology so exciting. We are not studying a completed story. We're living through the investigation itself. So far, we've explored dark matter, dark energy, quantum vacuum fluctuations, hidden dimensions, and the possible fate of reality itself. But one final chapter remains. In the last part of this documentary, we'll bring everything together. We'll examine the strongest evidence for the invisible universe, the biggest unanswered questions, the future experiments that could solve these mysteries, and the profound realization hiding behind all of it, that humanity may currently understand only 5% of existence, and the remaining 95% may completely transform our picture of reality. To be continued. Chapter 29. The evidence is everywhere. Let's pause for a moment. After everything we've explored, it's worth asking a simple question. How certain are we that this invisible universe actually exists? Could dark matter and dark energy simply be mistakes? Could astronomers be misinterpreting the data? It's a reasonable question. After all, extraordinary claims require extraordinary evidence. And that's exactly why scientists have spent decades testing these ideas from every possible angle. The remarkable thing is that the evidence comes from completely different sources. Galaxy rotation curves, galaxy clusters, gravitational lensing, the cosmic microwave background, large-scale structure formation, supernova observations. Each method approaches the problem differently. Each relies on different physics. Yet they keep pointing toward the same conclusion. The visible universe is not the whole universe. Again and again, independent observations converge on the same result. Imagine 5 strangers describing a hidden object from different angles. One sees its shadow, another hears its movement, another feels its shape, another measures its weight, another detects its effects on nearby objects. Individually, none possess the full picture. Together, they reveal something real. That's where cosmology stands today. We don't yet know the identity of dark matter. We don't yet understand dark energy. But their fingerprints appear everywhere, across the entire cosmos. And the deeper we investigate, the harder they become to ignore. Chapter 30. The Map of the Invisible. Imagine future generations looking back at our era. What might they remember? Perhaps they will remember it as the moment humanity first began mapping the invisible universe. Because right now, that's exactly what is happening. Astronomers are creating increasingly detailed maps of dark matter, using gravitational lensing, using galaxy surveys, using enormous supercomputers. Slowly, a hidden picture is emerging, a picture of an invisible cosmos woven around the visible one. The results are astonishing. The universe resembles a gigantic web, a network of hidden structures spanning unimaginable distances. Galaxies occupy only the brightest intersections. The visible universe is merely the illuminated portion of a much larger framework. Think of a city at night. You see lights, buildings, roads, but most of the underlying infrastructure remains hidden. Dark matter may be the infrastructure of reality, the unseen framework supporting everything else. And if that's true, then we are witnessing one of the greatest discoveries in human history. Not merely finding new objects, not merely finding new planets, but uncovering an entirely hidden layer of existence. Chapter 31. The Machines Searching for Ghosts. Across Earth, enormous machines are hunting something invisible. Deep beneath mountains, far underground, shielded from cosmic radiation, scientists wait, patiently, quietly, watching, listening, searching for the faintest signal, the faintest interaction, the faintest clue. Some detectors contain thousands of tons of ultra-pure liquid. Others use superconducting sensors. Others rely on advanced quantum technologies. Each experiment attempts the impossible, detecting something that barely interacts with reality. The challenge is immense. Imagine trying to hear a single raindrop during a hurricane. That's the level of sensitivity required. Yet researchers continue pushing boundaries. Because if a dark matter particle is detected directly, everything changes. Physics enters a new era. A new chapter begins. And perhaps, for the first time, humanity will finally identify one of the ghosts shaping the cosmos. But dark matter is only half the story. Dark energy remains even more mysterious. And solving that mystery may require entirely new ideas. Chapter 32. The Next Revolution. History often appears obvious in hindsight. Today, Newton feels inevitable. Einstein feels inevitable. Quantum mechanics feels inevitable. But when these revolutions occurred, nothing felt obvious. Confusion dominated. Old theories failed. New theories emerged. Reality transformed. We may be living through another such period right now. Many physicists believe dark matter and dark energy signal the limits of current understanding. A signpost pointing toward deeper physics. A warning that something fundamental remains missing. Perhaps new particles await discovery. Perhaps new forces exist. Perhaps space-time behaves differently than we imagine. Perhaps gravity itself requires revision. Whatever the answer turns out to be, history suggests one thing. The final explanation will probably surprise us. Because whenever humanity thinks it understands reality, the universe reveals another layer, another mystery, another secret, and perhaps the biggest secret remains hidden within the 95% we cannot see. Chapter 33. What if the universe is stranger than we imagine? Physicist J.B.S. Haldane once wrote something remarkable. The universe is not only stranger than we imagine, it is stranger than we can imagine. Those words capture the essence of this mystery. Because dark matter and dark energy challenge something deeper than physics. They challenge intuition. Human beings evolved to understand ordinary reality. Trees, animals, rivers, mountains. We did not evolve to understand quantum mechanics. Black holes, dark matter, or cosmic expansion. Yet science allows us to extend our vision beyond evolution's limits, to see beyond appearances, to uncover truths hidden beneath everyday experience. And every time we do, the universe becomes stranger, not less beautiful, not less meaningful, stranger, more profound, more mysterious. Perhaps reality contains layers we haven't yet imagined. Perhaps the visible universe is only the beginning. A surface phenomenon, a tiny window into something vastly larger. If so, then the greatest discoveries in history may still lie ahead. Chapter 34. The 5% Problem. Let's return to the number that started this journey. 5%. Everything you've ever seen. Everything you've ever touched. Everything humanity has ever observed directly. 5%. The stars above you. 5%. The planets. 5%. The oceans. 5%. Your body. 5%. That means 95% of reality remains hidden, unknown, unexplained. Imagine reading a book where 95% of the pages are blank. Imagine exploring a continent while only 5% appears on the map. That's our situation. And perhaps that's the most humbling realization of all. Not that science has failed, but that science has revealed how much remains undiscovered. The invisible universe isn't evidence of ignorance. It's evidence of progress. We only know about dark matter and dark energy because we've learned enough to notice their existence. The mystery emerged from discovery, not from failure. And that distinction matters. Because every unanswered question becomes an invitation to explore further, to investigate deeper, to continue the search. Chapter 35. The View from the Edge of Knowledge. Imagine standing at the edge of a vast ocean at night. You hold a flashlight. The beam illuminates a small patch of water. Everything beyond remains darkness. Human knowledge works much the same way. Science expands the beam, generation after generation, century after century. Yet every expansion reveals something surprising. the darkness grows too, because each answer creates new questions. Dark matter created new questions. Dark energy created new questions. The invisible universe created entirely new frontiers. And perhaps that's the true lesson of this story. The goal of science isn't to eliminate mystery. The goal is to understand mystery more clearly, to replace smaller mysteries with bigger ones, to continue pushing beyond the horizon. And right now, humanity stands at one of the greatest horizons ever encountered, a horizon hiding 95% of reality. Tonight, we followed the trail of a cosmic ghost, a ghost hidden inside the machinery of the universe. We discovered galaxies moving too quickly, invisible matter shaping cosmic structure, dark energy accelerating expansion, the possibility of hidden dimensions, the possibility of unknown particles, the possibility that reality itself contains layers we've barely begun to understand. And through it all, one fact remained constant. The visible universe is not the whole universe. Not even close. Everything familiar, everything observable, everything we've ever directly experienced represents only a tiny fraction of existence. The rest remains hidden, waiting, silent, mysterious. Yet perhaps that's not frightening. Perhaps it's inspiring, because it means discovery is far from over. The greatest scientific mysteries have not been solved. They're unfolding right now, somewhere in a laboratory, somewhere in a telescope, somewhere inside an equation. The next breakthrough may already be taking shape, and when it arrives, it could transform our understanding of reality forever. So the next time you look into the night sky, remember this. The stars are not the whole story. The galaxies are not the whole story. The visible universe is not the whole story. Behind the light, behind the matter, behind everything we know, lies an invisible cosmos, a hidden universe, a ghost in the machine, and humanity has only just begun the search. If you enjoyed this journey into the invisible universe, make sure to subscribe and join us for more explorations of space, cosmology, black holes, quantum physics, and the greatest mysteries of existence. Leave a comment below. What do you think dark matter really is? A new particle? A hidden dimension? A new law of physics? Or something even stranger? Because one thing is certain. The universe still has secrets. And together, we'll keep searching for them. Until next time, keep looking up and keep asking impossible questions.